Okay, so today's lesson is on solving logarithmic and exponential equations. The biggest thing I need you to make sure that you understand is that exponential functions and logarithmic functions are inverses of each other. So if I gave you some cute little equation like, how would you solve that? You would subtract 2. You would subtract 2 because subtraction is the inverse of addition. So you'd come in here and subtract 2 to both sides, right? What you do to one side, you do to the other. Okay, so if you have an exponential function, you are going to log it. If you have a logarithmic function, this is my favorite word. Are you ready? You're going to exponentiate it. So exponential function, you're going to what? You're going to log it. Logarithmic function, you're going to exponentiate it. Everything on the first page is what? Look, it's exponential. I know it's exponential because you know what I don't see? LOG. That's how I know it's exponential. Everybody on the front page of this sheet all have x's in their powers. So they are all exponential. So what am I going to be doing? I'm going to be logging them. Now, e's and ln's are a special pair. E's and ln's, ln is base e, right? So if I have an e, like I do in number 1, I'm not just going to log it. I'm going to ln it. Because ln is natural log, right? He is base e. So for e's, I go natural logs. So this is e to the x equals 72. So guys, that's exponential. I'm going to log it. Here's what you write. I'm going to ln both sides. Now, just like up there in my cute little equation, what happened when I had a plus 2 and then I subtracted 2? But what happened here? It canceled because they're inverses of each other. So guys, when I have a log and an exponential function, they cancel and the little x just falls down, just as cute as can be. Now on the other side, I have ln of 72. Don't you have an ln button on your calculator? So I'm going to ln 72. Let's go 3 decimal places, shall we? So 4.277. Good. Now, super paranoid people, watch what y'all can do. This is like, how do I know that's a 3? How could I check that that x equals 3 up there? 3 plus 2 is 5. Okay, well, I have 4.277. Now, did you chop off some decimals? Okay, so we're not going to be exact, right? Because that's not an exact answer. ln of 72 is the exact answer. 4.277. So if I take my calculator and I do e to the, what is it, 4.277? Is that right? Do you get close to 72? That's how you check it. Okay, now look at number 2. Do you pull the trigger on your ln, or do you need to clean first? You got to clean. So everybody's going to subtract 5 from both sides. Just a little algebra maintenance. Okay, that's an e to the, that is an exponential function with an e, so I'm going to ln it. What happens to the ln of e? Cancels, little x falls down, and I grab my handy dandy calculator and I ln 55. We're going 3 decimal places, so we get 4.007. 007. Okay, so what does number 3 have that's extra? He has a 3. Okay. Is that 3 movable like the 5 was movable on number 2? No. That he's tucked up in the power. So what are we going to do first? We're going to ln it. So I'm going to ln e to the 3x, and I'm going to ln 124. The ln of e, what happens? They cancel. I get 3x equals. Now on my calculator, I'm going to ln, what was it? 124. Okay, now listen. Let's be smart about this. If I chop decimals here, what's my next step after this? Divide by 3. If I chop decimals here and then divide by 3, isn't that compromising the integrity of my answer? So what I want to do is I really want that whole decimal. So in my work, I'm doing this. Like whatever that whole long decimal is, and I'm just going to leave it in my calculator. I am not rounding at the second step from the end. I'm not going to round until the very end. So I'm taking that whole decimal right there, and I'm going to divide him by 3 instead of chopping decimals and then dividing by 3. Why wouldn't you divide by? Because that 3 is up in a power he's not available to be divided by yet. He's unavailable. He's like up in a tower. You got to get him out of the tower first. So what are we going to get? 1.607. Super paranoid people could do e to the 3 times 1.607, and you're going to get 124-ish. Okay. All right, number 4. What are we going to do? Add 3. And then, yes. And guys, don't go decimal. I'm going to leave it as 5/4. I want the purest answers I can have throughout my problem. I don't want to go decimals until the very end. Okay, this is e to the, so what am I going to do? I'm going to ln both sides. Be very careful about all your levels, because once we have logs that have bases that we write, we're going to have like a main level and a downstairs and an upstairs. So just when you write, be very conscious about all your different levels. I need to type in ln of 5/4. Take that decimal and I'm dividing it by, is it 2? 0.112. Why do you think I do this little squiggly line? What would happen if I left that blank and I went to my calculator and I typed the ln of 5/4 and then divided by 2 and got 0.112? What could I mistakenly do? I could put the 0.112 here and then think, oh, I need to divide by 2, when actually I've already done that. So that's why I do that little squiggly line. That's like, oh, that's that big long decimal that I don't care about because I haven't divided by 2 yet. So that's why I do that. Okay, number 5, what you going to do? Subtract 5. And then? And then? So now I need to ln 12, and then I need to divide by 3. Everybody okay? Okay, this concludes the easy section. What I have found students struggle with is when to do what. Right now I've taught you one skill. If it's e to the, you ln it. That's the only skill I've taught you. But if you'll look at number 8, do you see an e in number 8. So you're not going to ln it. You're still going to log it, but you're not going to ln it. You only ln when there's an e. So I want you throughout the notes today to really pay attention to what am I doing and why am I doing it. Now, these 6 and number 7 still have e's in them. Any ideas? I'll subtract the 2, and then what? Are they like terms? If you divide by 3, you got to divide each term by 3. Y'all are thinking, that's good. You need to be a little creative. And the first step is not add, subtract, multiply, or divide. Yes. How? What kind of factoring? You can GCF? Is that what you're saying? So everybody up there has an e to the x? Then you can't GCF. Lobster's multiplying. The opposite of lobstering is what kind of factoring? A trinomial. This is a trinomial. This is really cool. Watch. E to the 2x is going to go e to the x and e to the x. Because, well, I'll tell you what. You tell me why. When you multiply, you add your powers. And guys, what's x plus x? That's where that comes from. So if I do this, if I do e to the x times e to the x, I get e to the 2x. Now, what are my factors of 2? Okay, is that going to get me a 3? I need a negative 3, so I need them both to be negative. And y'all see how that's going to give me a negative 3 e to the x? Now what do? What's your next step after you factor? I'm solving it. Yes. Set them both equal to 0 and solve them both independent. So add 2, and then what? Good. And then all you have to do is type those in on your calculator, although one of them you shouldn't have to type in, one of them you should know. ln of 1 is always 0. If you don't know, you can always type it in. ln of 2 is decimally, I got 0.693. Everybody cool? Okay, you try number 7. I got 1.099. Nope, that's the 3. Sorry. I got 1.099 and 1.386. Everybody good? Okay. So there are 4 things I have to show you today, and that's one of them. You now know how to solve an equation that has an E in it. Got it? You have only learned one of the 4. We are 25% of the way there. But we've laid the groundwork for number 8. This is not 241. That's like the cursor. I don't know what it's doing there. But do you guys agree that 8, 9, and 10 are all still what kind of functions? They're still exponential functions. You see your x up in your power? That's what makes him exponential. So if he's exponential, what are we going to do? We're going to log it. Now, before 1 through 7, we LN'd it because it was an E. We are now going to log it with whatever base the base of your exponential function is. So guys, in number 8, what is being raised to the power? A 4. So I am going to log, now this is where you got to watch your levels. I'm going to log base 4 both sides. 1 through 7, I log base E'd it, which was an ln. Here, I'm going to log base 4 to the x. Do y'all see what I mean about your levels? You got 3 levels. You got a main level, a basement, and an attic. What you do to one side, you do to the other. So this is what I did to both sides. Now, what happens when you log an exponential function? Right, they cancel. That was the whole point of doing that. The little x just falls right down. Now, how do you log base 424? Or what I teach you 2 days ago? What did I call that? You got to tall small it. Guys, the reason I don't want you to get in the habit of doing the math, the change of base button, because on your final exam, instead of decimal answers, they might have this. That may be what you have to choose from. Now, I'm fine with a decimal, but I want you to do it using the tall small. Now, do you have to use log base 10? Do you remember 2 days ago? What else did I show you that also worked? LN. You could also LN both sides, or LN the tall and the small. So I'm going to do log, what is it, 24? Close your parentheses, divided by log, where's your base? 4. You could have LN'd it. It's the same base. It's the same ratio. They aren't the same, but this is log base 10, and this is log base 10. This is log base E, and he's log base E. It's the same ratio. So 2.292. All right, number 9. What do you want to do first? Add 4. What do you think a really common I have lost my mind mistake is on this problem right here? People divide by 10. Can you see it? Yeah, that's not 10 times x. That x is up in his to the. So that is exponential, so I'm going to log it. Log base what? Log base 10, because that's the guy being raised to the power. So log base 10, 10 to the x, equals log base 10 of 38. Log base 10 of 10 cancels, just like the log base 4 of 4 canceled. Do you have to tall small this one? No, because your button is base 10. It just happens happens to work out that way for this problem. So you're going to log a 38 and you're going to get, I have 1.58. Is the next number a 0? Okay. Okay. What do we think about number 10? Add 4 and then divide by 2. So I have 3 to the 2x minus 5. Add 4, that's a 15. Divide by 2, that's 15 over 2. I'm going to leave it in its pure fraction form. That is an exponential function. I'm asking the same questions every time because when you get stuck on your homework, oh my God, I've completely forgotten what to do. That's where I want you to go. I want you to ask yourself, what kind of function is this? What do I do? It's the same thing with my Math 1 babies. When it's a plus 3, okay, what's being with the x? Well, it's a plus 3. What's the opposite of that? Minus 3. It's the same thing, just on a higher level. So this is an exponential function with a 3, so I'm going to do what? I'm going to log base 3 both sides. So the log base 3 of 3 cancels. And the 2x minus 5 falls down, and I'm going to get some decimal. So I need to log 15 over 2 divided by log of 3. So log 15 over 2. Nope. Nope. Try that again. 15 over 2 divided by log of 3. Now, do I want to write that answer down? What do I have left to do to that answer to solve this problem? I got to add 5 and divide by 2. So I'm going to add 5 and hit enter, and then I'm going to divide by 2. That's the one I want. So 3.417. I did tall small here. I did log of 15 over 2 divided by log of 3. And I got some decimal. This fell down, and then to that decimal I added 5, and then I divided by 2. You sure? Okay, so now you try 11. This is your last exponential function. After this, we switch to logs. I got negative 4.778. Questions? Okay, tell me one thing you've learned so far. Okay, if it's e to solve it, you're going to ln. If it's not an e, You're going to log it. With what base? So like in number 8, we log base 4, both sides. In number 9, we log base 10, both sides. And number 10, after we cleaned them up, we log base 3, both sides. Because you have to think about your test next week. These are all mixed up. So you got to be able to bounce from exponentials to logs, from e's to ln's. Like you've got to be able to, okay, what do I have? What do I do? It's very easy when they're all grouped in here together. Now, in your homework, they're all grouped in together. So what would be a good strategy for your homework or your test review? Skip around. Absolutely. Okay, do you agree that every problem on this page has a log in it? What is the opposite of logs? Exponentiate. Guys, to exponentiate something, you cause it to become the power. So you give it the base. To exponentiate it, to raise it up and make it be the power. So, what is the base of the log for number 1? E. Then you are going to E it. Now watch what I'm talking about. E to the ln of x equals E to the third. I've just taken that problem and jacked it up into the power of an E. Well, guys, if exponentials and logs are inverses of each other, what happens right here? That cancels and the x falls down. Now, don't we have an E button? So, E to the, what is he at, 3? $20.086. Are we okay? Okay, number 2, same problem, just has some extra stuff, some fluff around it that we need to clean up. What are you going to do first? Subtract the 5. Divide by 2. Now that you've prepped him, he's ready. That is an ln function, so you are going to what? You're going to E it because that's his base. You're going to exponentiate him with an E. Now, guys, if you don't want to rewrite it, look what you can do, because you can throw this in and make these powers really easy. E to the and E to the, if you don't want to rewrite it. Just keep your levels straight, because that ln of x is now in the attic, and that negative 1/2 is now in the attic. The E and the ln cancel, and the x falls down. So now all I have to do is E to the negative 1/2. 0.607. Okay, time out. Super paranoid people, watch this. I'm going to take the first part of number 2, and I'm going to plug in a 0.607 in for my x. So I have 5 plus 2 ln of 0.607. 4.001, and it's supposed to be a 4. So super paranoid people, do we like this? We love this because we can check our answers. Okay, number 3, what are we going to do? Divide by, anybody have another option? I would divide by 2 also because it's super easy. But does anybody see another option for that 2? Could it become a power? Aren't numbers out front of logs powers for the ofs? So if the 4 had issues over there and I didn't want to divide by 2, I could make that ln of 9x squared and solve it that way. It would be totally fine. But I can divide by 2. That's very easy. But why do you think I'm pointing that out? It's going to happen. Yeah, it's going to happen. Okay, so I've cleaned out all the debris, so am I ready to E it? Okay, so e to the and e to the, and those cancel. 3x falls down. I'm going to do e to the second and get some decimal. I don't care what that is. And then I'm going to divide that by 3. So e to the, nope, e to the, Lord. Let's try. E to the what? To the second. Gracious. Divided by 3. Here we go. 2.463. Okay, look at number 4. You cannot it. You can only do it once to one side and once to the other. He has issues. What can I do? Is that division? Could I condense that? How many logs would I have if I condense that? 1. Then could I it and it? Yes. Good job, Chloe. So ln of x over x minus 1 equals 1. I use my rules to condense. Now he's base e, so now I'm going to come in here and I'm going to it and it, and those are going to cancel. The little x over x minus 1 is going to fall down. E to the 1. What's e to the 1? Mm-hmm. Okay, algebra skills. Good. Times both sides by x minus 1. So I get x equals, does that just give you 2.718x minus 1? No. Yes, you've got to distribute that. 2.718x minus 2.718. Can you leave it? Times x minus 1. Yeah, and then your next step is going to be to distribute it. Because I got to get my x's together. So I'm solving for x. Who should I move? This guy? Over here? So I need to do 1 minus 2.718. So what's that going to give me? Negative 1. Yeah. My x's are, you're fine, here. So I need to get them together. So I need to do 1 minus 2 point, is it 718? 781. 718. Okay, so negative 1.718x equals negative 2.718. Please don't sit in here and just look up and copy what's written on the board. That does you no good whatsoever. You've got to be thinking. That hamster wheel up there in that beautiful brain of yours has got to be moving. He's got to be running around that hamster wheel. You got to be processing this. You can't just write it down. What we got? That was a good one. I like that one. Okay. Let's roll. Let's start rolling through these. What do we got? Subtract the 7. Next. E it. Good. You need to do e to the 2/3. Good catch. Good catch. No, please. I need all the help I can get. All right, number 6 is different. Why? It's not a natural log. His base is what? So, ladies and gentlemen, we are not going to E it. We are going to for it. Divide by 3 first. Okay, now that base is a 4. Just like this base was an E, we just don't write it. His base is a 4, so I'm going to exponentiate it with a 4. So 4 to the and 4 to the. Yes, the 4, log base 4, cancel. 6x falls down just as cute as can be. Guys, 4 cubed. We know what that is. 64. Then divide by 6. Oh, can you give me a fraction? Like, that's cute. Don't go decimal. Don't be calculator dependent. I know. Especially after all these decimals. I understand. Just don't forget you have a brain that works. Okay, number 7. Divide by 2. I like it. Now, he is a log. I know he's a log because I see the words L-O-G or the letters L-O-G. He is a log base 4. He is a log, so I'm going to, you don't log a log. I'm going to exponentiate it with a 4. I'm going to 4 it. So 4 to the and 4 to the, and those cancel. And the 3x falls down just as cute as can be. And what's 4 squared? And then you're going to divide by 3, and you're going to give me 16 over 3. You're not going to give me a decimal. If, okay, 8. Don't lose your negative on your log. And then divide by -1. Everybody okay? He is a log. I'm supposed to exponentiate him. Oh my gosh, he doesn't have a base. His base is 10. His base is always a 10. So I'm going to 10 it. Don't touch calculator. 10 to the -4th. 10 to the 4th, and then move it to the bottom. 1 over 1,000, 10,000, 100,000. 10 to the 4th means 4 zeros. The negative just means move it. Oh, dear Lord, we have 2 logs. They do have the same base. Can I 3 it? Now, you cannot 3 it, but can I 3 and 3 it? One on one side and one on the other? Does that get everybody? Yeah, because there are 2 logs and everybody's included in these logs. There are no stragglers. So I can 3 it and 3 it. Now look what happens. Oh, sweet algebra. Because now what? Yeah, so how would you solve that? Oh dear. Yeah, subtract the x, so that's 4x. Add the 1, that'd be an 8. So you go try number 10. Everybody cool beans? Okay. We've gone over all 4 methods, by the way. Did y'all catch that? Like we did exponentials with e's and with not e's, and we've done logs with ln's and not ln's. So you know everything. You know all the concepts. Sure. Here's one tidbit of knowledge. Tell me what the graph of a log looks like. 1, 0. So this is the graph of log of x. He has an asymptote here. Where does this graph never go? Who's negative? Because he goes where y's are negative. He doesn't ever go where x's are negative. So here's the rule. And this tells you why. You cannot log a negative number. So if you solve, I'm not saying you can't get x to equal a negative number. I'm not saying that. I'm saying once you get your x, if you plug it back in there, you better make sure it doesn't make you log a negative number. So if I have a 2, what's 5 times 2? Minus 9. No, I'm sorry, minus 1. 9. So I'm logging a positive number. What's 2 plus 7? So I'm logging a positive number. It's all cool. Again, I'm not saying this guy can't be negative, because if I had log of x plus 7 and I solved it and I got x equals negative 2, is that a valid answer? Yes, because negative 2 plus 7 is 5. I'm still logging a positive answer. But if I got x equals negative 9, would that be okay? And do you think that's a tiny bit of knowledge that people overlook when they solve these? So for logs, just make sure that your answer doesn't make you log a negative. So like, look at number 10. If I got x equals 1, could I keep that? No, because it would make that negative. So I'd mark him out and write no solution if that happened. And it's gonna. Okay. How many logs you got? Can I 5 it, 5 it, 5 it? No, no, no. It is addition which condenses to multiplication. So this side condenses to log base 5 of equals log base 5 of 36. I'm going to 5 it. 4x equals 36, so x equals 9. Wow, struggle. Are we okay? Were y'all just behind me? Does that make me log a negative number? So can I keep it? It's like finding a dog on the side of the road. Can I keep it? Can I keep it? Can I keep the 9? All right, number 12 has log, log, log. Can you 6 it, 6 it, 6 it? No, no, no. What have you got to do? We got to condense. We are professional condensers. 16 over 2. Where'd the 2 come from? Cube root of 8. 16 over 2 is 6 it. Don't log a log. 6 it. The beautiful thing. Does that make me log a negative number? No, so I can keep it. Home stretch, guys. We only have 5 problems left. Does it ever make you worry when I leave like extra space? Yeah, it should. Okay, the log part of this is not difficult. It's the algebra part we got to make sure you're okay with. Okay, I have log, log, log. Can I 3 it, 3 it, 3 it? No, no, no. I'm going to condense with division. So log base 3 of yes. Gonna make both the logs go, right? Okay. From here out, guys, it is math 1. It is algebra. So just be real careful. Sharpen up these skills a little bit. That would be 18. Can I keep it? Can I keep it? Huh? Huh? Can I keep it? I can keep a 1. What are you checking? To make sure it doesn't log a negative number. And I'm cool. Okay? Try the first couple of steps on number 14. I'm going to give you like a 20-second head start. Remember, when you condense, you still have your log. Everybody okay? I pulled out the E. Why did I pull out the E? Because it's an LN. Do you see a need to lobster? Yes. Let's see, that's a minus 3x and a minus 4x. He is quadratic. Became a power for the x. I kicked him up. He is quadratic. What do I need to do? Don't say factor. Not yet. What must you do before you factor? Get him equal to 0. Get him equal to 0, which is going to involve moving the x squared and combining like terms. You cannot factor squat until you're equal to 0. So I need to move him over here. So that would give me x squared minus 7x plus 6 equals 0. Now, what can you say? Hey, we're going to factor. So x equals, and That's like finding 2 puppies on the side of the road. Can I keep them? Can I? Can I? 2 puppies? Why can I not keep? I want to keep the 1. Because if I plug a 1 in to here, 1 minus 2 would be a -1, and that makes me log a negative number, and that's no bueno. Can I keep the 6? Are you checking both? Actually, are you checking all 3? Okay. I can keep the 6. Now, sadly, what do I have to do if you don't mark out the 1? I have to count it wrong. Don't make me do that. Okay. 15 and 16 are different because they don't all have logs. It's not log, log, log. It's log, log, no log. Suggestions? The logs are on the same side. If we keep them together, can I use my condense rules? So I'm going to take that and multiply it by that. Can I go ahead and distribute? Are y'all okay with that? 25x squared minus 75x equals 3. Everybody okay with what I just did? Okay. Now, if I was a referee and I had a flag, I'd throw a flag right here on what I just wrote. What's wrong with what I just wrote? The math is fine. What are you logging? What is your of? No, that's not 10. The 10's not your of. The 10 is your base. I don't want you to do anything to the numbers. But this is incorrect. Like if this was an English class, this is bad grammar. Nope. Nope. Y'all are thinking, though. That's good. Keep thinking. Except I don't have time for y'all to keep thinking. If all of this is being of'd, right? The way that I have it written, this is log base 10 of 25x squared. Pause. Minus 75x. This has to be in parentheses because it's all being logged. Okay, now, I have a log. It is base 10. What do I want to do? So 25x squared minus 75x falls down, and that equals... He is quadratic. Oh, can we do something to make life easier, please? Yes. Take out a what? 25. Good gracious. There are 4 25s and 100. There are 10 hundreds and 1,000. Therefore, there are 40 25s and 1,000. Is that right? Oh, that's right. Five and 8. Do I need to slow down? So x is going to equal a -5 and a +8. Can I keep them? Can I? Go back to the original problem. I cannot keep the -5. I can keep the 8. Okay, in an essence of time, let's skip 16. He's identical to number 15. Let's go do 17, and if we have time, we'll go back. I want to do number 17 because I want to point out something very important, and I'm going to go kind of fast. This -1 is not being logged. He's a straggler. Do you see how you have logs on different sides of the equations? I'm going to add him, because he's negative, over and I'm going to add the 1 who's the straggler over to the other side. Then he turns right into the other 2 problems that we've just done. So I'm going to condense. So I'm going to multiply. And I'm going to go ahead and distribute. Are y'all okay with that? Everybody see what I've done? Everybody cool? I condensed. So this is addition. So I condensed it with multiplication. So I multiplied him times him and got that. So now I'm going to 10 it. Ten to the 1. 10 to the 1. 10. He is quadratic. What are the factors of 10 that subtract to give me 9? I want a negative 9, so negative 10 and a positive 1. I know that was fast. But once you get past the first step, it follows number 15. Guys, look at your homework. Whoa, whoa, whoa. Look at your homework. Flip to the back of your homework. Man, I didn't do it. Okay, sorry. The answers are posted. I recommend, like, randomly doing problems on your homework. Like, go out of order. Smart Breakfast, I'm here in the morning if you need me.